Hello class. Today we're going to talk about BBOA. So the first thing that we need to know is, what does BBOA stand for? Well, BBOA stands for the building blocks of algebra. And what that really means is that we now know that there are some parts that go together. What we've looked at so far is we've had an expression and we've been able to evaluate this expression for given values. We've also been able to evaluate this expression using a t-chart where we have several different values. And we've learned that if I evaluate this t-chart, it creates a set of coordinates that allows me to create a picture of that expression on a graph. So today what we need to do is we need to learn the fourth part, and that is to create a visual model. So for the models that we're going to be using today, we're going to use this particular key. A long open shape is going to be considered an X, and a long closed shape will be considered a negative X. An open square counts as a constant, so this counts as 1. And a closed square is going to count for a negative 1. So let's look at a couple of expressions and see if we can build their models. So here is our first expression, 3x plus 5. So what we want to do is we want to build that using the key that we just saw. Okay, so if I have 3 x's, that means I need 3 open longs. And if I need a positive 5, I need 5 open squares. And you could arrange it however you wanted to. There's nothing particular about the arrangement. Okay, so that would be the model that would represent 3x plus 5. Well, what if I gave you negative 2x plus 3? Well, now we have a negative 2x, so that means we need to have some closed longs. So we have 2 closed longs and 3 open squares. And that would be the model of negative 2x plus 3. Well, what if I gave you a 5x minus 6? Well, the one thing is you cannot model a subtraction problem. Okay, because we're building models, which means we're putting things together, which means the model has to be an addition problem. So just like we have been doing, if you see a minus, we change subtraction to addition, the next number to its opposite. Now I can build the model. So now this says 5x, so that means I need 5 open longs and 6 closed squares. And that would represent our 5x plus negative 6. One last one. What if I gave you negative x minus 4? Well, again, we can't model a subtraction problem, so we have to change it. So I'm going to change subtraction to addition, next number to its opposite. Now I have a negative x, which we know is just negative 1x. So that means I have 1 closed long and 4 closed squares. And that would be the model of negative x plus negative 4. Now, how does this all fit together? Well, what we're going to be doing is we're going to do something, a little activity called BBOA, or putting all 4 building blocks together. The model with the expression, with the t-chart, and with the graph. So in this particular one, we have an expression. So the first thing we have to do is we've got to model it. So we've got x plus 5. So that's going to be 1 open long and 5 squares that are also open. So I can get off of that. Okay, and then 5 of these little squares here. So let me pull this together and drop these up here. Okay, so we would have a model that would look something like this. Okay, so that's 1x and then 5 squares. Now we know that this expression, it can actually go in 2 places. It goes as the expression, but we also know that it's going to go in the t-chart right there. So this x plus 5 is the same thing as that y. So now we evaluate. So we plug in negative 2 plus 5 gives us 3. Negative 1 plus 5 gives us 4. 0 plus 5 gives us 5. So what are we doing? We're counting by ones. So the next one should be 6 and 7. And then I can take this t-chart and I can place it on a graph. So negative 2, 3. Negative 1, 4. 0, 5. 1, 6. 2, 7. Now to finish off the graph, we connect the dots, extend out on both ends, and add an arrow. But what we're going to do today is I'm going to give you the model, and I'm going to ask you then to create the expression, give me the t-chart, and graph it. So in this particular one, we've got 2 open longs, so that's going to represent 2x, plus, because we put it all together, that's the plus 3 closed squares, so that's going to be a -3. Now another way of actually writing 2x plus -3 would be 2x minus 3, and both of those would be the same expression. Now I'm going to take this same expression, I'm going to place it up here where the y is, and we're going to evaluate this expression. So I plug in my -2. 2 times -2 is -4, and then -4 plus -3 gives us -7. And then my x value now changes. So -1 times 2. So 2 times -1 gives me -2. -2 plus -3 gives me -5. 2 times 0 is 0, plus -3 is -3. So we find out that we're increasing by 2, so then the next one would be -1, and the last one would be +1. And now we take this set of coordinates and we graph it to create its picture. So -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. We play connect the dots, and we extend out past. And that is BBOA.